I found one of these jars the other day, which is, I think, going to be perfect for a candle, a fake candle. And on the top of it, more interestingly, it's got this clear top. And so it's just going to be the right fit for a 2-volt solar panel. It'll actually go underneath, so keep out of the weather. And what that'll mean is that all the electronics and everything will be underneath. Normally what I do is to spray the inside with a little bit of white spray paint to make it sort of opaque. So we'll do that first and we'll come back and we'll put it together. Interestingly enough too, there's going to be a Padauk involved because some PCBs have come in which are Padauk based candles. So new hardware and new software, it'll be fantastic. Let's start with spraying this guy though. So I might have laid it a bit too heavy maybe, but that's been coated. So that's fine. So now it's the electronic part. So we'll put aside the jar for the moment and let's have a look to see what we've got. So, well, we need one of those, so I'll put that away as well. So this is the PCB that is the latest incarnation. I think I've got a couple here actually. Let's have a look at these side by side. So we've got, yeah, 2 different versions really, and we're going to use the black one. Let's go through the green one first. So 100 nanofarad across VCC and ground. There's VCC on this side and ground on that side. A bit unusual, but this is a Padauk based version. Then I've got a Zener and a Schottky, and they're SMD versions. And I've actually extended the pads a little bit so you could maybe put a couple of different sizes on there. I've broken out all the pins of the microcontroller. And then we've got a through-hole inductor, a through-hole 47 microfarad capacitor. We've got space here for our solar and our battery. Now this is a little interesting one. So this is an SMD QX5252, and that's with the extra pin. So this one over here is the one that we're familiar with, that we've seen on so many videos before. And that's the 4-pin version, but the SOT23-5 version has this extra pin, and it's called LS, and I've broken it out to a selector. So what you would do is you would select whether you want the QX5252 to take its cue from the solar panel and turn off during the day while it's gathering light and then on at night time, or you can actually, with the selector here, you can pull it to ground. And that tells the QX5252 to be on the whole time, and that can have its uses as well. So, but we won't use that version. We'll use this version here, and it's pretty much the same, I guess. So we've got our 100 nanofarad capacitor across VCC and ground in the same spot here. Our QX5252 is the more sort of TO92 based version. There's our solar and our battery connections, our inductor here, 47 microfarad. Oh, that's interesting. It's got a 0 after it. Okay, so I must have put an extra. I'm not sure why that's there, but anyway, 47 microfarad capacitor, and Schottky and Zener are both through hole. So yeah, let's start that process. So I'm also going to need an adapter for the microcontroller itself, for the Padauk. It's a PFS 154, and I'll put up the pin out for it. And what I'm going to do is to, I guess, yeah, what's that, 5 that way, so connect it up like that. And I just don't know, ooh, it's going to be a bit tight for the capacitor. What I'll probably do is have a bit of a chat to start with, and then when I get bored, or I think you guys might be getting bored, I'll just switch it into fast mode, and we can watch the whole thing in quick mode. All right, so let's put that on here. So first thing to do, where are my special glasses? Here we go. All right, old eyes need special glasses for SMD work. And the PFS 154 is an SMD chip, and I'm just wondering in hindsight why I didn't put an SMD form factor there. And so it was a bit of a late night design, so I might go back and do another generation where I can just solder this directly to the PCB instead of having to go via an adapter. I mean, for the moment it gives me probably a little bit of flexibility, but yeah, ultimately once everything is worked out in terms of the design, it would be quicker and easier. It just doesn't want to line up. It would be quicker and easier to, here we go, solder it directly to the PCB. Well, that's not right. A few seconds of I don't know what, and then it stops. So there's a few things to have a think about for this circuit. I mean, one of the things is that the PFS154 I've not had in this type of circuit before, except, you know, on a breadboard. But that worked, so yeah, I'm not sure if that could be the problem. The QX5252 regulates the output of current via this inductor, and I have chosen a particularly high one. I think this is 470 microhenries. So we could swap in 100 or 330 microhenry inductor, and that should bump up the current coming out. And it could be a current issue. Maybe it's trying to supply the LEDs and saying, whoa, this is a little too anemic for me. I know the A-Tiny13 can cope okay, but perhaps the PFS154 is not so inclined. I've got another QX5252 to throw in there as well. And also, I guess what we could do, I mean, the amount of current coming out of VCC here and then going via the LEDs and through to the inputs should be minuscule. It should be around the order tops of, I think it's 10, 11, 12 milliamps. And of course, it's PWM as well, so it's throttled quite back. If you think about PWM as being from 0 to 255, I think the top one of these is something like 180 or something like that. So yeah, trying to limit the amount of juice going through. But anyway, we'll start with the inductor. I'm interested to know maybe also what's happening voltage wise. So if I pop this in ground on this side, and we'll see if it'll let me pick up VCC on this side. It should be a steady 3 volts. And I'm not getting, well, it's stopped working. Oh, I suppose it's because, let's try and get a weight on here to stop that from kicking up. And then we'll just try and see if I can get a reading. So it should be around 3 volts. Yeah, it is. It is fluctuating quite a bit, which is not good. So yeah, I'll start with the inductor, see if we can get some more juice going through, and we'll go from there. One quick inductorectomy. That's measured. It's indicating 100 millihenry, but measured at 80. So we should have considerably more current coming from the QX5252 for that. And okay, wow. Well, I wouldn't have expected that would be the problem, but there we go. So higher current and a lot more stable. I might now try, because that's pretty, well, it's a bit brighter than maybe what I wanted, just to put 100 ohm resistor in there, and I may have a play with different types of resistors actually. Whoop, and there we go. Okay, so that's not good. I mean, it's an improvement. I don't know how many seconds that was. There's some good PWM action. Let's see if I can focus in on that. It's a bit hard to tell. Let's see if you guys can see that. Yeah, it's a bit tricky to see. And that's why the resistor might help. All right, we'll put a resistor in there and see if that helps. So a 100 ohm resistor in there now. See if that has any effect. Well, firstly on the LEDs, but secondly on the stability of the microcontroller itself. Oh, well, that's nice. Actually, the PWM is a lot easier to see at that lower current as well. So I've always been operating under the assumption that the PFS 154 has its own sort of version of current limiting through the GPIOs. But I'm going to have to investigate that a bit further. So I have put a current limiting resistor in there. On some of the older candles involved in the ATtiny 13, it was actually a pot. I think it was a 500 ohm pot. So that might be worth exploring as well. And it's not such a bad idea to be able to actually change the intensity of the light depending on what you're using that light for. So yeah, it's been up for a while. I'm going to say that is a success. I'm going to put the whole thing together in the container now and trial it for a couple of nights and see how it goes. I think I'll come back and say whether or not the circuit's working this time. I'll get back to you. I'm generally happy with how this one's turned out. A couple of things that I'll change. The 100 microhenry inductor here has meant that the current is probably still a little too high. So I'm going to go with a 220 microhenry. And interestingly, I pulled this one from a packet that I ordered probably 2 or 3 years ago, which I'd labeled as 220. And when I went to test it, and I'm in the sort of mindset of always testing components before using them these days, because there's nothing worse than trying to troubleshoot a circuit where the problem is actually the component and not the way that it's been designed. So this one's coming up as a resistor, and I'm thinking that's a bit strange. So I pulled one from a separate batch, which is also labeled 220. And in the same tester, it is coming up as an inductor, and roughly what it's supposed to be as well. I think it says 0.19 millihenry, and I'm looking for 220 microhenry. So that's in the ballpark. At least it's not coming up as a resistor. So although I'm loath to do it, I went and had a look at the bands that you need here, and this one is red, black, and silver, which indeed is 220. This one, orange, red, gold, and silver, comes up as I think 3.6 microhenry. And now I wonder how many projects that I've put these guys in without testing them, which has caused grief in the past. So now I've correctly labeled them 3.6 microhenry in the buckets, and I've also ordered some more, which of the 220 microhenry inductors, which I'm hoping will be, as advertised. So yeah, that's interesting. The other thing is that the 100 ohm resistor here, coming out of 3 volts, is still a little bright at night time. It may seem strange, but it is. So I'm going to actually use that as a base, and I'm going to put on top of that a little pot here, and this one is from 0 to 500 ohms, and that should allow you to sort of wind back the brightness of this LED combo, 3 LEDs in there, and that should overall get this thing through the night. It almost does get through the night. It's pretty much down to, at the moment, around about, I think, just thinking maybe 9 hours, and I'd probably like it to be about 10 or 12 for the dark Tasmanian winter. So I'll make those changes. I'll change the 100 microhenry inductor here for a 220, and I better make sure I pick up the right one, which is this one, and I'll add this to it, and then we'll test it, and I think that will be about right. The iPad's struggling to make any sense out of it. In real life, it's throwing a little bit more light, and the light is more of a goldeny, orangey colour than the sort of yellow that's coming across. And at night, it does fill up a fair proportion of the room, of course, as your eyes adjust. So that's the PFS 154 based candle. First of the new PCBs off the line. A little bit of fiddling around with the components, but a 220 microhenry inductor seems to give the right balance between enough current that the processor can work, but not too much that it wastes it, and so we can see this thing going through the night pretty easily now. And the other combo is a 100 ohm resistor, which is going into those LEDs because the Baduk sinks current, and that's in combo with a 500 ohm potentiometer, and so that light can be adjusted. So yeah, that is pretty good. I'm going to call that. That is a circuit working. See you next time.